Day 275 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 295, find median from data stream. The difficulty level is hard, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description and get you some, y'all. Now, let's see what the question says. Question says the median is the middle value in an ordered integer list. If the size of the list is even, there is no middle value, and the median is the mean of the two middle values. For example, in an array of integers 2, 3, and 4, the median is 3. For example, in an array of integers 2 and 3, the median is 2 plus 3 divided by 2, which is 2.5. Implement the median finder class. Median finder initializes the finder object. Void add num int num, which is the function add nums, adds the integer from nums from the data stream to the data structure. Double find median, which is a function called find median that returns a double, returns the median of all elements so far. Answers within the 10th to the negative 5th power of the actual answer will be accepted. So let's go ahead and look at these examples now that we know what the question is asking, right? So we can know exactly what it is that they want us to do. So let me go ahead and just copy and paste this over here so I can make it make sense to y'all a little bit easier, a little bit more. My bad. Let me just clean this up a little bit. Boom. That's the input. Come up here, put input. It'll come down here, put the output. This the output right here. Boom. So let's just go ahead and read through it, right? So the input, we have an array of function calls and initializers. First thing we do, we initialize median finder. Well, I'll do it over here. First thing we do is we initialize median finder. Then we call add num. Then we call add num again. Then we call find median. Then we call add num again. And then we call find median. These right here correspond, each one of these elements in this array correspond to each one of these strings in this array, right? So this corresponds to the find median. Then this corresponds, we add num, meaning we add the number 1 to the data structure. Then this corresponds to the second add num, meaning we add the number 2 to the data structure. Then we call find median, which means we're going to find the median of those two, 1 and 2. Then this corresponds to the third add num, meaning we're adding 3 to the data structure, and this corresponds to the last find median, which is going to find the median of all of the elements in the data structure thus far, and this is the output as well. Each one of these corresponds with each one of these as well. So first we're going to find median, that's null. Then we add num, that's null. Then we add num again, that's null. Then we find the median, so the median would be 1.5. Then we call add num again. Then we call find median again, and the median is changed because we added something. So now the median is 2.0. So let's go ahead and break this down. So look at this explanation so we can really make it make sense in case that doesn't make sense to anybody. So let's come over here. First thing we're going to do, right? Explanation says median finder equals new median finder. So that's when we initialize it. Boom. So we could just initialize it. We don't have to add anything to the data structure. Boom. Then find median calls add num, and we're adding 1 to the data structure, right? So we just add 1 to the data structure up here. Boom. We get rid of that because we already called it. Boom. Then we call median finder add num again. This time we're adding 2 to the data structure. So now the data structure has 1 and 2. Boom. So we could put, we could put a 2 up here. Boom. So we added 2. Boom. Get rid of this because we already called it. Now we're calling find median, right? So call find median. The median of this is, remember, it says up here, right here, if the size of the list is even, there is no middle value, and the median is the mean of the two middle values. So since, as you can see, this is an even number of elements in the data structure, so what we need to do is we need to add 1 plus 2, which is going to give us 3. Then we take 3 and we divide that by 2, and that's going to equal 1.5. So boom, back down here, call find median, return 1.5 because 1 plus 2 divided by 2 is going to give us 1.5. Boom. So that's where this 1.5 comes from. Yeah, we could get rid of these as well since we already called them. Boom. Find median, called it. Output was 1.5. That's where this 1.5 came from right here. Boom. And right here. Boom. But now we already did that, so we could get rid of it. Boom. Now we're right here. We're right here. Oh, we need to add nums. We need to add num3. We need to add 3 to the data structure. Let's get rid of this too. Boom. So let's go ahead and add 3. Boom. Then we add 3. We get rid of that. Get rid of that. Get rid of that. And now, right here, last call of find median. Right here, boom, median finder. We call find median, and that the median of this is 2. Boom, because remember it says up here, excuse me, y'all, the median is the middle value in an ordered integer list. As you can see, they gave us the example in order already, so we just need to find the middle value. And in this case, the value is 2. So that's why this output is find 2.0 when we call the final find median. And remember that, remember that this function, the find median function, returns a double. So that's why it's 2.0 and it's not just a 2. Because you never know, like remember over here it was 1.5, so that's why it has to be a double. So in this case, output is 2.0 because that's the middle value. Boom. So now you get rid of this. And now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult. We should get through it fairly easily. So let's get started and see how we're going to do this. First thing we are going to do, we need a property to store the current median value. So we need to create that, right? So we could just say, private var, call it median, colon, and we can cast that as a double, put exclamation point. Now we need a flag to indicate whether the median needs to be recalculated, because remember, every time we add a number, the median is going to need to be recalculated. So we're going to create a flag to let us know if it needs to be recalculated or not. So we're going to say private var, then we'll say needs update, and we set that equal to true. Boom. Then we need an array to store the numbers that have been added. So we could just say private var, we could call this nums, set this equal to square bracket integers to an array of integers. So we say square bracket int, square bracket, and then we'll initialize it with the parentheses like so. Now, come down here, we need to create a helper function. So this is going to update the median function if it's needed. I mean, update the median, not the median function, but update the median if we need to update the median. So we're gonna say private func, we could call it update if needed, put the parentheses, open up the brackets. Let's get started. Now, first we need to check if the update is not needed, then we could just exit the function. So we'll just say guard needs update, else open up the parentheses, return, just like that. So if it doesn't need an update, we could just return. Boom. Now we need to sort the numbers to find the median. So we say nums dot sort, open up the parentheses. That's all we had to do. That's going to sort the numbers for us. Now we need to find the middle index. So in order to do that, we're going to say let half n for half index equal nums.count divided by 2. And once again, that's going to find the middle index for us. Boom. Now we need to check to see if the count is even or odd. So in order to do that, all we have to do is say if nums.count mod 2 equal sign dot 0, open up the brackets. That means this right here is going to check to see if the count is even. So if the count is even, that means the median is the average of the two middle numbers. So in order to do that, we just say median equals, open up the parentheses, we'll say double, then we'll open up the parentheses again, we'll say nums, square brackets, half end, come outside the parentheses, the square bracket and the first parentheses, but not the last parentheses, and we're gonna say plus double, open up the parentheses, nums, open up the square brackets, we're gonna say half end minus 1, come outside of all of the parentheses, and we're just going to divide that by 2. So that's to handle if the count is even. If the count is not even, we're going to say, or if the count is odd, we're going to say else. We could just say median. We could set the median to the middle number. So all we have to do is say median equals double, open up the parentheses, nums, square bracket, half, end, just like that. Now we need to reset the flag as the median is now up to date. So we could just come right here and we could say needs update equals false because we just updated it. Boom. So now that we have our helper function, let's get into the other functions. We're not going to need this init either, so we could just get rid of that. First thing we need to do is we need to append a new number to the data structure. So when we call this add nums function. So in order to do that, all we're going to do is say nums dot append num. It's that simple, right? Boom. Then we need to set the flag to indicate that a new median needs to be recalculated because we just added a number. That means we're going to need to recalculate the median every time we add a new number. So we need to update the flag. So we're going to say needs update, set that equal to true because it needs a new update because we just added a number. Now we need to create the function, and this function is going to return the current median. So in order to do that, we could just call update median, or excuse me, update if needed function. The function we just created, our helper function, we could just call that and then come down here and we can return the median. So we say return median, just like that. Now that should be all she wrote, y'all. Let's go ahead and run it, make sure it runs like it's supposed to. Let's see. Oh, and it's accepted. Let's submit it. Make sure it stays accepted after we submit it, because you all know how LeetCode can be. Just because it's accepted when you run it doesn't mean it's going to be accepted when you submit it. But this time it is, y'all. Look at that. 649 milliseconds beats 17.56% of users with Swift, y'all. Not too bad. Not too bad at all. We'll get those numbers up as we continue down our LeetCode journey, but right now we just want to be able to have the skills to be able to answer the question that is presented in front of us, and I feel like this is a good solution, easy to understand solution, a solution where everybody can learn something from. So I hope y'all learned something today. So go ahead, get one more look at the code before we leave for the day. One more look at the code. That's the first half of the code. Second half of the code. Boom. I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. I'll see y'all then.